My name is Pamela Vasquez and my topic is Cortex A8 Vehicle Navigator using RT Linux. Introduction. Cortex A8 processor was the first to use the ARM v7-A architecture. The Cortex A8 implements extended ISA in the first ever fully superscalar designed from ARM. It has a full dual issue pipeline, meaning the Cortex A8 can also issue any two instructions that occurs at the same time. The ARM Cortex A8 processor has the ability to scale in speed from 600 MHz to greater than 1 GHz, meeting the requirements for power-optimized mobile devices needing operations in less than 3 milliwatts and performance-optimized consumer applications. The processor has a number of features which makes ideal for use in high-performance end products. The Cortex A8 supports Neon technology, allowing it to take advantage of accelerated multimedia and DSP processing.
Welcome to Dell Tech Support. Processors are all about speed, but what else is there to know about them? In this video, we'll explain what a processor is, how it works, and what its main features are. The processor is a chip responsible for calculations. It makes all the logical decisions, which are basically all the tasks your computer does. From the simplest thing as opening a window to the most complex, like completing a 3D animation. For this reason, the processor is known as the brain of the computer. To understand how it works, imagine this scenario. We have a processor, and next to it there is memory RAM and inputs coming from the output devices. Your hard drive, mouse, keyboard, and monitor. The mode of communication between them is called the motherboard. It is responsible for linking the processor to all the components of your computer. The processor executes three basic functions: receive input data, process this data, and provide output data. But what exactly does all this mean? When you type in some text, for example, each letter entered is input data. The processor receives this data, processes it, and provides the output. In this case, everything that you type will appear immediately on your screen. All this is done in a fraction of a second. There are other types of processors too, which may be installed on your system, but every processor contains several important features. Here are the main ones. The socket. The socket is a type of physical connection between the processor and the motherboard, and it is responsible for transmitting energy to the processor. The core. The cores are responsible for the processing speed. The more cores a processor has, the more functions it can execute simultaneously without overloading your system. The clock. The clock is responsible for defining the frequency that your processor will use to execute one task. It's measured by hertz. This means the amount of cycles that can happen in a given amount of time. In this case, in seconds. For example, if a processor has a 2 GHz clock, it can have up to 2 billion cycles per second. So the higher your clock frequency is, the lower the execution time will be, which for you means a faster processor. The cache. Basically, the cache is the auxiliary memory of a processor, where the most accessed data that will be processed is identified and then stored. The processor accesses this memory and is able to execute the action faster because it's more readily available. This is one more important factor that has a direct impact on the processor speed. The more cache there is, the more quick storage capacity you have, which results in a faster speed. If you have any questions or need help, contact our social media support through Facebook or Twitter. Thanks for watching, and be sure to check out our other tips and tutorials on this channel. See you next time!
Definition. The Cortex A8 processor is a high-performance and low-power application processor that provides full virtual memory capabilities. It is designed to meet the needs of markets requiring high performance with power efficiency, often integrating web connectivity.
I'm Russell Crane, Product Marketing Manager for ARM Microprocessors here at Texas Instruments. I'm pleased to introduce TI's most performance and cost-optimized ARM Cortex A8 solution, the AM335X generation of Cortex A8 ARM MPUs. Starting at just $5, these MPUs deliver the performance of an ARM Cortex A8 at ARM 9 price points. This solution balances the performance, power, and peripheral integration that's critical to meeting your product requirements. This full-featured line of MPUs consists of a 3D graphics accelerator, integrated LCD and touchscreen controller, high-performance connectivity and design flexibility with sophisticated peripherals, and flexible power management modes that consume as little as 7 milliwatts of power. The AM335X ARM MPUs come with a variety of development options that include a complete evaluation module in addition to a low-cost open-source board, the BeagleBone, from beagleboard.org. Additionally, you'll receive full free software development kits for Linux and Android, as well as industry-leading third-party real-time operating systems. As TI continues to drive innovation by offering cutting-edge ARM solutions that balance performance, power, and cost, we're excited to bring a highly optimized solution like the AM335X ARM Cortex A8 MPU to the market. The integration of key features that further reduce complexity and system cost give you an infinite number of design possibilities, and we can't wait to see where the AM335X ARM MPUs will take you. For more information, please visit ti.com/AM335X. Thanks for watching.
Key benefits. Neon technology. Neon technology can accelerate multimedia and signal processing algorithms such as video encode decode, gaming, audio and speech processing, image processing, and sound synthesis. Dynamic branch precision. To minimize branch precision penalties, it achieves 95% accuracy across a wide range of industry benchmarks. The predictor is enabled by a branch, target, and global history buffers. JCell technology. RCT Java acceleration technology to optimize just-in-time and dynamic adaptive compilation and reduce memory footprints by up to 3 times. Trustzone technology. Allows for secure transactions and digital rights management.
Hi there, this is Ranjit from tech2bus.com, and in this video I'm going to explain microprocessors used in our smartphone. Because every couple of days I get into arguments with people when I suggest them a particular model of phone, and they argue that the other X model also has the same, let's say, 1 gigahertz processor, and why not that? It's very difficult to explain in the YouTube comments. The reason is that let's say you have phone A and phone B, and if both of them are even, let's say, 1 gigahertz, and let's say the phone one is running on the ARM Cortex A5 processor and the second one is running on the ARM Cortex A9, definitely the second one will blow away the first one in performance. And to explain you the same, let me talk a little bit about these ARM processors. I'm going to talk specifically about Android phones because most of these phones use this ARM processor. About 95% of the phones use this ARM processor. And ARM is a company which actually is a little bit different from other microprocessor manufacturers like Intel or AMD. They do not actually produce the processors themselves, but they license their technology to other vendors. And the big 4 vendors that actually produce these chips are, the first one is NVIDIA, second one is Qualcomm. They make that Snapdragon processor. Third is Samsung, the Exynos processor line, and the last one is Texas Instrument, the TI OMAP processors that we see. Again, it's not just limited to these four, but these four are the big ones. And before going ahead, let me explain you a little bit about ARM processor. Generally, you'll find ARM processor in mobile phones, tablets, etc. And the thing is that if you noticed a phone, the biggest gripe that we have these days with our smartphones is the battery life. And if you open up a phone, you'll find a huge chunk of the portion is taken up by the battery. And if you see our modern smartphones, these are actually mini computers because they have a processor, they have a GPU, they have memory, and they have a lot of radios like Wi-Fi, Bluetooth, etc. So actually you can say that this is a miniature computer. And if you notice, again, it will be ideal to pack in all these things in a very small space. And again, it should be very power efficient. Otherwise, it will drain the battery really fast. And actually in smartphones and tablets, everything is on one chipset, generally known as SoC, called system on chip. So everything, your processor, GPU, memory, and other things will be on that chipset. And as I told you, these four biggies, that's the NVIDIA, Qualcomm, Texas Instrument, and Samsung, make these. And ARM does not mandate that it should be like this or whatever. They just license their architecture, and these manufacturers again tweak it according to their liking. But let me get back to this ARM Cortex processor. On the lowest end, you'll find the Cortex A5. And next we have the Cortex A8. Over that we have the Cortex A9. Generally the smartphones that are manufactured in 2012, the most of the high-end phones are using this Cortex A9 architecture. And as of now, the highest one that is available is Cortex A15. We have just started to see some of the new phones using the Cortex A15. For example, the newly launched Nexus phone by Google, that is Nexus 4, is based on the Cortex A15 architecture. The chip actually is manufactured by Qualcomm, and it's the S4 Pro. That's a quad-core chip. Again, Nexus also launched this new tablet that is Nexus 10, and that's also based on the Cortex A15. But it is manufactured, the chip is manufactured by Samsung. It's the Exynos dual-core chip. Again, one more thing that you need to be aware is, and I know this is a little bit confusing, the the Samsung Exynos chip that is used in the Nexus 10, though it's just a dual core chip, it beats the quad core chips like this Tegra 3, etc., that are based on the ARM Cortex A9 architecture. So again, that also has to be in the consideration. Again, as you move up the ladder, the efficiency and the power increases. And actually,
applications. An autonomous vehicle following a desired path by a real-time kinematic GPS includes designing prototype, PCB, layout, finding sensors and components for the system, designing and simulating the control system, and making software. The ARM Cortex A8 based controller is running the system. There are a lot of Linux versions available, but after 2.6 all versions are similar despite of their version numbers. In this case, it is necessary to use Linux kernel 3.2.31 since it's not the latest and it's not very old. Compared with other versions, it contains less reported bugs. To be able to have the system working, it is necessary to do some configuration before running the applications. A specific compiler is used in ARM processors instead of C compiler, such as GCC or Visual C. It's also necessary the code sorcery ARM Linux toolchain. It uses a mainline GCC that has a stable ARM support.
ARM-based mobile devices have enjoyed dramatic growth over the last decade, and their functionality has increased at a similar rate. As they enable more immersive experiences, the expectations for more powerful features and greater performance are increasing dramatically, all with the same requirement for a longer battery life. Energy-efficient performance has always been a driver behind ARM innovation. low-power techniques have evolved from clock gating through dynamic voltage and frequency scaling, multiple cores, specialized accelerators, then the rise of GPU compute, and most recently, ARM Big Little processing technology. Big Little is the latest in a series of innovations that have allowed huge improvements in mobile performance within a constant power budget. Big Little is about delivering peak performance and maximum energy efficiency on the same SoC. This is achieved by pairing bigger, higher performance processors with smaller, high efficiency processors. These processors are connected by a
Finally, conclusion. The Cortex A8 processor is the fastest, most power-efficient microprocessor yet developed by ARM, and an autonomous vehicle can reach an accuracy of plus 5 centimeters by using this processor. Even when it runs for several hours, it shows its reliability and robustness. It is a great success that an autonomous vehicle can run that smartly. Thank you.